Hello and welcome. My name is Lisa and I'm working for the Potsdam Institute for Climate Impact Research. In this video, I will talk you through specific climate change projections and sectoral impacts in Somalia from now until 2080. Such context-specific information is crucial to support decision-making towards a more climate-resilient and also peaceful future. The climate projections shown in this profile are the product of a joint collaboration between Weathering Risk and the Agrica project from Potsdam Institute for Climate Impact Research. We draw on the data and modeling work done by PIC's EasyMap project. EasyMap stands for the Intersectoral Impact Model Intercomparison project and is a climate impact modeling initiative which provides data that summarizes current and also future climate change impacts across existing models for different greenhouse gas scenarios. Here is an overview over what will be covered within this video. To start with, I will very briefly explain you how to read the map plots and line plots that we will be providing, and then I will turn towards the climate changes, the projected ones, and also the sectoral impacts. So part 1 will provide you with projected climate changes relating to temperature, precipitation, and sea level rise. Part 2 will then assess some sector-specific climate-related risks, and there we will be focusing on future water availability, crop yields, health implications, but also impacts on GDP growth and biodiversity. I'm now quickly going to explain you how to interpret the plots that we will be providing. So this line plot that you can see here provides you with sea level change projections until the year 2080 for 2 different greenhouse gas emission scenarios. The blue color represents the low emission scenario RCP 2.6 that is in line with the Paris Agreement, and the red color represents the medium to high emission scenario RCP 6. The lines that you can see here provide you always with the best estimate, which is the multi-model median, so the median of all models underlying each projection. And then you have the shaded areas that are surrounding those lines, and those represent the likely range and also the very likely range, which indicate a probability over the projected changes of at least 66 or 90% respectively. This line plot that you can see here, the second one, provides you with information on soil moisture change in Somalia. And again, you have the blue line that represents the low emission scenario and the red one, the medium to high emission scenario. And as you can see from this plot, the shaded areas, so the likely and the very likely ranges, are relatively large, which means that the different models underlying the projections predict quite different changes in soil moisture, and thus that there is quite a high uncertainty over those projected changes. And projections with a high level of uncertainty, such as this one, must be evaluated with great care when used for policy decisions. And in order to help you to assess those provided plots, we will display you a symbol to indicate the projections which are subject to such high levels of uncertainty. And you can see the symbol in this slide. Furthermore, we will be providing map plots which display regionally explicit climate information that are averaged over an area of approximately 50 times 15 kilometers. And this example here shows you projected changes in air temperature under RCP 2.6 in the upper row and under RCP 6 in the lower row. And the leftmost column always provides you with a baseline period that is around the year 2000, and then you have the other columns that show differences relative to this baseline period. If you have a close look at this map, then you will discover those dots in there. And if those dots are present, then this means that at least 75% of the underlying models agree on the sign of change depicted for the specific region. So from this plot, we can derive a high certainty over an increase in temperature basically across all regions and under both scenarios. And here we have another example of a map plot that shows you the projected tree cover change for Somalia. And this one is an example of very high uncertainty, since as you can see when you look very closely, the dots within the map plots are pretty much everywhere absent. So this is due to underlying projections that basically project very different changes, with some projecting an increase and some a decrease in deforestation. I will now guide you through the climate change projections and the sectoral impacts, for Somalia, and I will start with the climate change projections. This line plot depicts the air temperature changes for Somalia until 2080 as compared to the pre-industrial period. And as you can see here, air temperature is projected to rise under both greenhouse gas emission scenarios with high certainty. While under the lower emission scenario, RCP 2.6, climate temperature can be projected to rise to around 1.6 degrees, by around 1.6 degrees until 2030, and by around 1.9 degrees until 2080. The projected air temperature will rise significantly stronger under RCP 6 until 2080, as it will be rising by approximately 2.8 degrees according to the best estimates. This map plot shows regionally explicit information around temperature changes as compared to the baseline period around the year 2000. And air temperature is projected to rise with high certainty all over Somalia, from what you can see from this plot. Under the lower emission scenario, this increase will affect the whole country. However, the coastal regions will be slightly less affected, and temperatures can be expected to increase by 0.7 to 0.9 degrees until 2030, and by 0.9 to 1.2 degrees until 2080. If we are looking at the higher emission scenario, RCP 6, temperature changes will develop more or less similar to the lower emission projections until 2030. But the long-term scenarios under RCP 6 project significantly stronger increases. And we can expect temperatures to rise by up to 2.4 degrees until 2080 in the most affected regions. And regional variability, as you can see in this map, will be also much higher, as coastal regions will be less affected than the interior of the country. In line with rising mean annual temperatures, the annual number of very hot days that you can see on this plot, and that is defined as the number of days with daily maximum temperatures that are above 35 degrees, is also projected to rise with high certainty all over Somalia. And we can expect this rise under both scenarios, though, as you can see, it will be much stronger under RCP 6, where it will increase by over 100 very hot days in central and southern Somalia until 2080, and might increase by up to 150 more very hot days in the most affected regions. And given that Somalia already has one of the highest mean annual temperatures in the world, this depicted rise in temperature and also in the number of very hot days poses increasing risks to the living conditions of the people in Somalia, as I will also show in the projections on sector-specific impacts. On this plot, you can see the sea level rise, and the sea level is projected to rise steadily under either scenario in Somalia. So until 2030, sea levels will increase by 11 to 12 centimeters, and by 20 and 21 centimeters until 2050 as compared to the year 2000, depending on the scenario. And then if we look at the range between, or the time frame between 2050 and 80, this increase will be much higher under RCP 6. However, we can also see that the uncertainty about the level of increasing sea level also rises the further one looks into the future, but it is still very likely that the sea level will rise somewhere between 32 and 58 centimeters until 2080, depending on the greenhouse gas emission scenario. Let me now turn towards precipitation projections. Precipitation projections are in general less certain than the ones around temperature change. As you can see, precipitation will be subject to high interannual variability and will overall very likely increase over Somalia in the long run, with a much stronger and also more continuous increase under RCP 6. And under this high emission scenario, despite the high interannual variations, precipitation projections show an increasing trend with a much stronger increase from the year 2040 onwards. However, the range of projected precipitation changes is quite high, so by 2080 we can expect an increase by, to be ranging by somewhere between 14 and over 60 millimeters a year. And under the lower emission scenario, precipitation changes will vary very strongly, but in the long run we can also expect an increase or a slight increase as compared to the year 2000. And in view of the overall water shortages that Somalia is facing, these projections could be interpreted as a quite positive development. However, those strong interannual variations and also the projections on heavy precipitation events, which I'm going to show you in the next slides, suggest that the expected increase in rainfall will become also much less regular and much more intense. On this slide you can see regionally specific changes in precipitation, and as you can see, those are subject to high levels of modeling uncertainty in most regions and also across the scenarios and timeframes that are depicted here. So this uncertainty is particularly high for southern but also for central Somalia and is most prominent under RCP 2.6. And under RCP 6, overall we can say that projections are more certain, but nevertheless show significant uncertainties in the short-term projections, so until 2030. And generally, projections show a decreasing trend for the south of Somalia and an increasing trend for northern Somalia, where precipitation will be rising by up to almost 60% by 2080 in the most affected regions, and most strongly affected will be Galmudug and Puntland. Generally speaking, heavy precipitation events are expected to become more frequent and also more intense in response to climate change. And geographically explicit information on the number of days with heavy precipitation events show an increasing trend in northern Somalia and a decreasing trend in southern Somalia under both scenarios. And those trends are in line with regionally differentiated precipitation projections that I have presented before. However, we also have to say that, as you can see, model agreement under both scenarios is quite low for many regions, which is why we need to be careful when assessing those plots. So after having gone through the projected climate changes, let me now turn towards the sectoral specific impacts. I will start with future water availability. So these plots depict future water availability per person and year, and you have the figure on the left side that represents a scenario that does not consider population change, and then you have the scenario B on the right-hand side considering population change. Overall, we can say that both projections show high intra-annual variability, and as one can see, the very likely range of water resources is extremely high for current and also future projections, and this translates into very high levels of uncertainty. However, what we can say is that assuming a constant population level, so as you can see on the picture to the left-hand side, projections show some variations under both scenarios, and overall a very small increase in per capita water availability by 2080. This is particularly true under RCP 6. If we assume a changing population scenario, so the figure to the right-hand side, this per capita water availability will decline by half until 2080 and will range somewhere between around 220 and 2,600 cubic meters under RCP 6 per person and year, of course. And this range is quite high. However, if you look at the best estimate, this projects a drop to just over 1,100 cubic meters per capita and year until 2080. And given that a country is said to be under water stress, when water supplies drop to below 1,700 cubic meters per person and year, this decrease is quite alarming. This map shows you future water availability from precipitation, or in other words, the runoff rate. And as you can see here, this strongly varies depending on the region and the scenario, and is also highly uncertain. But overall, we can say that we will see a decreasing trend for southern Somalia and an increasing trend for northern Somalia under RCP 2.6, and a general increase in water availability under RCP 6 in the long run. But the very south will instead see a decrease. However, model agreement for most regions is very low, and we need to consider these uncertainties when taking policy decisions. Agriculture is amongst the sectors most exposed to climate change, and it will impact crop yields to very different extents, also depending on the crops grown. And in what follows, we will provide you with projections of crop yields for some of the major crops that are grown in Somalia, and those include cowpeas, rice, millet and sorghum, and also maize. The crop yield projections that we will provide are considering 2005 level land use patterns and agricultural management practices that include irrigation and fertilizer use. As we can see from the plot on the left-hand side, which shows cowpeas yields, models result in overall positive trend for cowpeas yields under both scenarios. Until 2050, those projected yields will develop relatively similar under both scenarios. However, in the long run, those yields can be expected to be considerably higher under RCP 6, where yields are projected to very likely increase to somewhere by between 35 and over 60%. The plot to the right-hand side shows rice yields or rice yield projections, and those can overall also be expected to increase under both greenhouse gas scenarios, though the different models project very different results, which translate into a very high uncertainties around the increase in future results. So this increase in future results will be quite rather low, comparably low under RCP 2.6, but under RCP 6 until 2080, this increase will range to somewhere between 36 and 154%, only in the likely range. And as you can see from the plot, this range will be even significantly higher in the very likely range. The projections of millet and sorghum that you can see on the left-hand side and maize that you can see on the right-hand side both show very high interannual variabilities, and thus it's quite difficult to derive a clear trend for future crop yields. And furthermore, the modeling uncertainty is very high for both projections, as you can see, because the underlying models project different directions of change. The high modeling uncertainty around maize yield projections also becomes apparent from looking into geographically explicit information as shown on this map. Overall, maize yields will not change significantly as shown before, but what we can see here is that they can be expected to increase in northern Somalia and decrease in southern Somalia. However, particularly under RCP 2.6, those projections are highly uncertain across the country, and we cannot derive many reliable information from those projections. The certainty around maize yield changes is much higher under RCP 6, but nevertheless, particularly for southern Somalia, shows significant uncertainty. In northern Somalia, certainty is higher, and we can expect an increase in maize yields, which may rise by up to 80% until 2080 in the most affected regions. Overall, also geographically explicit rice yield projections that you can see on this map are highly uncertain and vary across the country and the underlying scenario. Under RCP 2.6, you will see an increase in northern and central Somalia and a decrease in southern Somalia until the year 2080. And under the high emission scenario, overall, we can say that rice yields are projected to rise, though with extremely high regional variations that will range by a decrease by up to 12% in the south and maximum increases in crop yields that may rise by over 400% until 2080 in central Somalia as compared to the year 2000. But given these extremely high uncertainties that have been shown on these plots, all crop yields projections displayed here actually must be evaluated very carefully when they are used for policy measures. I will now turn towards health impacts. Generally, rising temperatures and the increase in the number of very hot days will have severe health implications. And this plot shows the exposure of the Somalis to heat waves at least once a year. And as we can derive from it, the population affected by at least one heat wave a year is projected to increase to over 20% until 2030 under both scenarios. And this rapid increase that we can see here will slow down quickly after 2030. However, modeling uncertainty will also increase from 2030 onwards. This plot shows you future heat-related mortality. And as you can see, it will very likely rise following the projected increase in the number of very hot days and also the heat exposure that I've already shown you. We can expect approximately 3 days per 100,000 people a year by 2030 if we, according to the best estimates under both scenarios. And why under the lower emission scenario this number will remain relatively stable until 2080, we can expect a much stronger rise under RCP6, though the uncertainty over this rise increases the further we look into the future. We can, however, say that the number of heat-related mortalities will very likely range between almost 6 and 11.5 deaths per 100,000 people a year until 2080. And if we look at the best estimate, this one projects 10 deaths per 100,000 people per year until this time, and this would actually translate into an increase by a factor of almost 8 if we compare it to the year 2000 levels. Here you can see the exposure of GDP to heat waves across Somalia. As you can see, this is also projected to strongly increase under both scenarios. So median model projections for RCP 2.6 show an increase from around 8% in the year 2000 to around 17% in 2030 and will rise to almost 23% in 2080. Projections under RCP6 are similarly high, so according to these projections, if we look at them, we can say that with high certainty heat waves will very negatively affect GDP growth in the future under both scenarios. Increasing temperatures and changing rainfall patterns are also projected to impact and influence ecosystems and biodiversity. And this map plot shown here shows model projections of species richness, which includes amphibians, birds, and mammals. And overall, we can see that this richness in species is projected to increase in the very northern mountainous regions of Somalia and to decrease in the southern regions of Somalia under both scenarios. However, there's comparingly higher uncertainty because of higher model or less model agreement for central and southern Somalia, while model agreement in the mountainous regions is significantly higher. And it's also important to note that the models shown here in those projections do not include any impacts on biodiversity loss from human activities, such as from land use, for example, which have been responsible for significant losses of global biodiversity in the past. So this was a quick run through the most important climate change projections and sectoral impacts for Somalia. And if you want to have more information around the projections and also around more plots, please have a look into the Climate Risk Profile Somalia that you can find on our homepage. As shown by the projections, Somalia is highly susceptible to future effects of climate change, and the scale of climate change impacts in Somalia and also elsewhere within the world heavily depends on future greenhouse gas emissions, which is why global mitigation measures are key to limit future socioeconomic impacts. So to pave the way towards a more climate resilient and also peaceful future, we need to scale up risk-informed anticipatory action and also adaptation measures that are based on comprehensive climate impact projections, such as the one provided within this video. And in this context, it's also important to plan around the uncertainties that we have shown. So if you would like to know more about the future climate risks in Somalia or the methodology behind our projections, please have a look into our Climate Risk Profile Somalia, which also includes a short summary around the projected impacts and changes that I have presented here. And you can find all relevant information on our homepage. For any further requests, please do get in touch with us. Thank you for watching.